I'm television meteorologist Mike Fairborn. You know, we really have a remarkable climate here in Minnesota. Over a typical year, the temperature swings from a low of about 40 degrees below zero to a high of about 100 above zero. Not many other places on Earth can claim that or would want to. But no matter what the weather is like, one thing that remains the same is the need to make and repair utility cuts on our streets and roads. I'd like to go through the whole process of a utility cut repair and show you what I've learned from Minnesota's road maintenance professionals about how to do the job right. But before I show you methods that lead to successful utility cut repairs, I think it'll be useful to take a look at a failed repair and talk about how it probably got that way. Through a lot of research, it's become clear that lack of soil compaction is the most common problem with utility cut repairs. This kind of failure is the result of insufficient compaction, which in turn could have been caused by using the wrong type of compactor or trying to compact too much soil at once. Or it could be that the soil was just not suitable for compaction. It may have been too wet, too dry, frozen, or it may have contained too much organic material, such as roots or peat. Finally, it could be that the crew simply neglected to compact the soil at all. And this cut probably wasn't compacted well enough because the repaired area was too narrow for the compactor to do an adequate job. Settlement can also occur next to a patch and then develop into a pothole. That kind of problem is usually the result of a void under the pavement that could be caused by undercutting the pavement during excavation, or the soil may have caved in toward the center of the excavation while the cut was open. In either case, it's difficult to put soil into the void and impossible to compact it effectively. Failure can also result from placing the edge of the cut directly in the wheel path. The joint between the repaired and the original material is likely to be the weakest point in the patch, and you don't want vehicles driving over that constantly. Finally, here's a typical problem with concrete patches. This temporary patch is rough and not flush with the adjoining surface. I've watched a couple of utility repair projects, and the first thing that struck me was that the crews are out there dealing with emergencies. So I can understand how backfilling and surface repair may seem to be less important parts of the job, and I can understand why there's a tendency to hurry the job on a cold winter day. But a correctly repaired utility cut pays us all back in several ways. First, you, the workers, are more likely to receive praise than criticism. At the same time, your employer and the taxpayers will save the cost of redoing the repair. And all of us will have a smoother ride and less traffic congestion, fewer delays, and reduced vehicle damage. It's important to point out that the correct methods for making and repairing utility cuts are well known. Decades of research and experience on Minnesota streets and roads have shown what works and what doesn't. So let's take a look at the most important aspects of doing the job right. First, if necessary, be sure to get an excavation permit from the city, county, or state. The permit will state the requirements for your job. Next, plan the size of your excavation. Obviously, it has to be big enough to get at the problem you're going to solve, but also be sure you allow plenty of room for your equipment, including any necessary safety devices. And be sure the cut is big enough so you can meet any applicable sloping requirements. But before you dig, remember that there's always more underneath the pavement than you know about. So be sure to call Gopher State One Call for utility locations. In non-emergency situations, they have 48 hours to locate all utilities in the area where you need to dig. In emergency situations, they should be there within 2 hours. Next, set up the right traffic control devices for the safety of motorists and your crew. Each setup will be different depending on existing conditions. Always consult and comply with the MnDOT Field Manual for temporary traffic control zones. If you're cutting concrete, you'll use a full-depth saw. But there are several ways to cut asphalt, and most cities and counties have specific preferences. They may require that you use either a saw or a jackhammer with a spade bit, and some also allow you to mill. In any case, it's important to make a vertical cut. Then, when you're finishing the job, your patch will be full depth and square. That will help to avoid raveling of the patching material, and it looks better. As you excavate, it's critical to think about safety. Decide on the shape of your cut in response to the soil types and soil conditions you encounter. To avoid dangerous cave-ins in all but most shallow cuts, you need to either slope the sides of the cut or install shoring or a trench box. You can find all the necessary dimensions and slope angles for excavations in this OSHA specification, beginning at paragraph 1926.650. Another good reason to slope your excavation is to avoid undermining, the tendency of the soil to fall out from under the pavement. And be sure you don't undercut the soil that's under the pavement with your backhoe. Obviously, it will be difficult or impossible to compact soil that's under the edge of the pavement. And as I said before, that's a very common cause for pavement failure. When you've finished your repair work, it's important to think about what you're going to use for backfill. There are several points to make here. First, most specifications say you must use approved backfill material devoid of any large objects, and that's especially important for the fill you put under and around a pipe or cable. The biggest piece you should put into the hole is about 3 inches in any dimension, and try to eliminate anything sharp. The impact of compaction can easily cause a rock to puncture a cable or pipe. In most cases, the fill that came out of the hole is the best thing to put back in. It's important to have consistent soils under pavement so there will be consistent responses to temperature and moisture changes. If there are different kinds of soil under the pavement, they may expand and contract differently, leading to either settlement or heaving. But there are exceptions to the rule that you put back what you took out. You should dry out or haul away soil that is saturated with water. And when you're working in the winter, be sure to remove and haul away soil that's frozen into a big chunk. In these cases, backfill with dry, unfrozen soil of the same type you found in the excavation. Now, we come back to compaction. As I said earlier, it's the most critical step for long-lasting pavement repair. Every utility cut repair in a street or road needs to be compacted. You need to give the most attention to compacting the top 3 to 4 feet of soil because that's where most settlement occurs. To do the job right, you need to place the top few feet in lifts 1 foot thick or less, and you need to compact each lift until it's fully consolidated. If you're working with sandy soil, use a vibrating compactor. But if you're placing soil with a lot of clay content, be sure to use an impact machine. Vibrating compactors cannot compact clay soils effectively. You also might find that the permitting agency requires you to use flowable fill. That's a specialized material that needs no compaction but has almost zero settlement. Flowable fill is more expensive, but it works very well in situations where you can't compact soil, like under a large pipe. Of course, the last step is to close things up. In the winter, you have to put in a temporary patch and then return when permanent materials become available in late spring or early summer. For concrete pavements, most cities and counties allow you to replace less than a full panel if your work site is relatively small. Be sure to check with the permitting agency to see what the rules are on this and whether you need to install dowels and rebars. Whether you're working with concrete or asphalt, be sure to square off the area to be patched if you didn't already make the cut in a rectangular shape. Use an approved tack coat on the pavement edge to help make a good bond between the old pavement and the patch. If you're replacing asphalt that's more than 3 inches thick, you need to do it in more than one lift. It's important to compact each lift. And if a lift has cooled completely, apply a tack coat before placing the next lift. Well, I've left out most of the detail, but that's still a lot to remember. So I think it'll help if I go over the most important points again. Get any necessary permits and call Gopher State 1 call. Plan and arrange for traffic control. Your life depends on it. Use approved equipment for cutting the surface. Trim the edges of the surface cut to the right size and shape and follow OSHA safety requirements as you excavate. Usually backfill with the soil you took out, but replace saturated or frozen soil with an approved replacement. Place the top 3 to 4 feet in lifts 1 foot thick or less and compact each lift. Cut back the surface so you place a neat rectangular patch. When you're placing an asphalt patch, use thin lifts and, if necessary, tack coats between lifts. And remember, you're out there to solve a problem for your community. You don't want to leave another one in its place because everyone benefits when you do the job right. Your utility cut repairs will be safer and longer lasting. You'll leave a smoother driving surface, and just as important, you'll have the pride that comes from knowing that you did the job right.